Now we want to calculate the density of the bar. Rho is equal to mass divided by the length times the width times the height. We first calculate the result from the measurands. This gives us a result of 2.69953 grams per cubic centimeter. We keep lots of digits until we know the final uncertainty. We now calculate the fractional uncertainty of this result by following this general rule. If the measurement quantities, x plus or minus the uncertainty in x, y plus or minus the uncertainty of y, and so forth up to z plus or minus the uncertainty in z, are used to compute a result r, which has the form r is equal to c times x raised to the a power times y raised to the b power times however many terms in your formula times z raised to the d power, where a, b, and c, and so forth up to d are constants with no uncertainty, such as 2 or minus 1, which is how we divide two terms. X divided by y is the same as x times y raised to the minus 1 power. Then the fractional uncertainty in r is given by the square root of the sum of the squares of the fractional uncertainties, where we multiply each uncertainty by the exponent constants. Make sure that all uncertainties are 95% CIs and are random and uncorrelated. So we rewrite our density formula to match this pattern. We get rho is equal to mass times length to the minus 1 times width to the minus 1 times height to the minus 1. We now plug in our fractional uncertainties into the formula, adding the sum of the squares. After squaring, we get this result. Notice that the first term, corresponding to the fractional uncertainty in the mass, is 4 orders of magnitude smaller than the third term. When we add these, we're mostly left with just the largest term, plus a little bit from the last term. The fractional uncertainty is thus the square root of 0.00723, which is 0.085. Recall that this is the fractional uncertainty for our measurement, 8.5%. To get the final uncertainty, we reverse the calculation that we did to calculate the fractional uncertainty. The uncertainty in the density is equal to the density measurand times the fractional uncertainty, or 0.23 grams. So our final report of the density is rho is equal to 2.70 plus or minus 0.23 grams per cubic centimeter, 95% CI. Reviewing the steps for calculating the uncertainty for the product of measurements is to 1. Calculate the result measurand using the measurands of your measurements. 2. Calculate the fractional uncertainties of your measurements. 3. Add the sum of the squares of the fractional uncertainties times any constants, and take the square root. 4. Multiply the fractional uncertainty by the result measurand to get the final uncertainty. 5. Adjust the digits of the uncertainty and measurand to fit our conventions. And 6. Report the final calculation.